Hi everyone! In this video I just want to give you a brief example of how we can work with units and how we can see do they make sense for our equation. So let's have a look at a very famous formula. Let's look at E equals mc squared. So we can imagine little Einstein sitting here with his lovely haircut telling us E equals mc squared. Now E is the kinetic energy of a body, and that's so kinetic energy, and it's measured in joules, which are kilograms meters squared per second squared. Another way we could write that if we like is kilograms times meters squared divided by seconds squared. Just using our power laws there. Okay, m is the mass. And we know in our SI units, mass is measured in kilograms. C is the speed of light. Speed of light. And C is measured in meters per second, or meters per second, however we'd like to write that. Okay, so let's have a look at the units. On the left-hand side, that's nice and easy because we've only got one thing there. On the right here, we've got a squared sign, and we also have a multiplication. So let's see what happens to our units when we deal with those. Okay, so on our right-hand side, we have mc squared. A nice way to work with units and understand what's going on is let's let m equal 1 kilogram and we'll let c equal 1 meter per second. In real life the speed of light is a lot higher than that, but we're just working with the 1 to make our calculations a lot easier so we can see what's happening with the units rather than watching what's happening with the numbers. Okay, so if we have mc squared, that's 1 kilogram times, now in brackets, 1 meter per second, all squared. So it's really important if we are squaring a number, make sure that we square the units as well. Alright, so that's 1 kilogram times 1 squared times meters squared times seconds to the negative 1 squared. Okay, so 1 kilogram times 1 times meters squared times seconds to the negative 2. Okay, we can look at just the numbers here. We've got a 1 and a 1. 1 times 1 is just 1. Now let's look at the units. We've got kilograms meters squared per second squared. So that's like having 1 kilograms times meters squared divided by seconds squared. And that comes out to exactly what we had for the left-hand side over here. So because our left-hand side units are equal to our right-hand side units, we're all good. We can say this equation makes sense. Okay, another one we can have a look at. Let's have a look at E equals m squared c. So let's get this equation a little bit wrong, and we'll see if we can work it out just based on the units that it's wrong. So just as before, our energy is in joules, which is kilograms meters squared per second squared. Our mass is in kilograms, and our speed of light is in meters per second. Okay, so let's have a look at the right-hand side. M squared c. Let's let m equal 1 again, so 1 kilogram. We'll let c equal 1 meter per second. So we have 1 kilogram squared times 1 meter per second. Okay, so we have 1 squared kilogram squared times 1 meter per second. Our 1 squared times 1 is just 1. Now we have kilograms squared meters per second. And we can say left-hand side does not equal right-hand side, and we're done. Okay? So just looking at the units, we can work out, does a formula make sense, or does it make absolutely no sense at all? And here it doesn't make any sense at all. Another thing to remember with units before we stop is that if we have, for example, the addition of some units, so let's say I studied for 2 hours and I ate 3 pieces of cake. We can't just add 2 hours plus 3 pieces of cake because our units don't match. Okay, that's the same as we cannot subtract those, our units don't match, we cannot deal with these things at all. Okay, what if I said, I think there are, an egg is 1 kilogram. Oh, hang on, that's really bad. Okay, I have 1 kilogram of eggs. And that 1 kilogram of eggs is 16 eggs. How many eggs per kilogram? Okay. So, what we can do is we can say, well, 16 eggs divided by 1 kilogram, and we get 16 eggs per kilogram. That's all I'll go through today. I hope we can see that you cannot add things that don't have the same units. We can work out units that aren't SI units at all, so eggs aren't SI units, but sometimes it's handy to be able to convert between a carton of eggs and a single egg. Up here, we can work out, does a formula make sense just based on its units? And then over here, we did the same thing. We worked with our units. We saw how they worked together and worked out that E equals mc squared could be correct. So the only idea with the units is you'll be able to tell if something could be correct. We won't be able to tell if it definitely is or not just based on the unit.